Okay, so you should have just done your bell ringer and you also watched that video because remember, these are questions that a lot of us missed, so you need to get a walkthrough of it just in case. Just in case. Okay, so what are we going to do today? Today it says, I can explore and report evidence of continental drift. Ooh, what's that? We're going to find out. Okay, so you have your guided notes pulled up. Remember to fill them in as I go. So we talked on Tuesday about this crazy idea that all of the tectonic plates, that top surface of the earth, that top crust and that top part of the upper mantle, we talked about how those tectonic plates are constantly in motion. Very slow, but they're constantly in motion. So there's actually a name for that theory, and that is called continental drift. Makes sense to me because the continents, or North America, South America, Africa, Europe, all of those are the continents. And drift just means they moved. So it's just this theory that says that the continents have slowly moved over time. Now, this wasn't always what we had in mind. Like, this was kind of a new, crazy idea, and it's honestly kind of new. It first came up around 100 years ago by this German guy named Alfred Wegener. Now, I know I said Wegener and I spelled it with a W, but he's German. And a lot of the Germans, they pronounce a W like a V, Wegener. So that's his last name, Alfred Wegener. So he's the one who really is the head of this idea that the continents are constantly in motion. Now, before we knew this to be true, what people believed was that, the continents are where they always have been. They are permanently in that spot. So that idea was called permanentism, which makes sense. It's just that, they are permanent and they don't move. So this GIF shows it going really fast, and obviously they don't move that quickly. We would probably feel that. So this is just the idea, and it shows that it's happening over millions of years. So this is kind of a sped up version of the continents drifting. So there was this idea that maybe at one point we were all connected as one. We call it a supercontinent, until after many, many years, after those plates slowly move and move and move, they look how our Earth looks today. They're all separated. So that is continental drift. So we're going to go into, why do we think this is what's happening and how do we know? Because that's kind of a crazy idea. And if you have a crazy idea, you got to be able to back it up. So how did Alfred Wegener back up this idea? So there are a couple of ways we have evidence, or a couple of things that we use to determine that it's true. So part of the idea is that the Earth is constantly making new crust. So the top layer of that Earth, that brittle crust, that hard rock, the idea is that we are constantly making and recycling that crust. That sounds kind of weird, so what is that? So first, this is always going to happen at something called the mid-ocean ridges. So that is basically just a fancy way of talking about mountains that are underneath water in the middle of the ocean. So if you look at this red line right here, or if you look over here, it's actually labeled, it says mid-ocean ridge. That is your underwater mountain. So this is where the new crust is going to be made. Now, what's actually happening? So the Earth will go through this process at that mid-ocean ridge called seafloor spreading. So this part is a little wild, so bear with me here. The seafloor is actually going to spread, right? Seafloor spreading, makes sense. And that hot magma that is in that asthenosphere, we remember that, asthenosphere, that hot magma is going to rise out in between those two tectonic plates once they separate. So once that hot magma comes up after that seafloor separates, it's going to cool down and form hard rock, which we talked about that when we talked about the rock cycle, when we talked about igneous rocks. When that hot magma cools and forms a rock, that's what's happening here. So those two plates sitting underneath the ocean, they are going to separate. That hot magma is going to come up and cool and harden until it forms a new rock, which is now new crust. And that's why we call them mid-ocean ridges, because that new rock is coming up and it's forming kind of like a little mountain underneath the ocean. So this is something that scientists have actually studied over and over again. It does actually occur, so we know that this is true. So clearly something or some part of the tectonic plates are moving to create that new crust. So we know at least underneath the ocean, those plates are definitely moving for sure. Now, we know of a couple of other clues that are a little bit more obvious. You know, they're kind of no-brainers when we talk about clues that support the continental drift theory. So one clue, and this one is my favorite, I think it's really cool, is that if you look at all of the continents on a map of the world today, if you look right here, this is a map of what our world looks like today. We are over here at the bottom, kind of at the bottom of North America, South America, Africa, Asia. There's all the continents. Now, if you look at the continents, they actually fit together really well, almost like puzzle pieces. So if you look up here, South America tucks into Africa beautifully. In Africa, especially, look right there, Africa and Asia, they fit together like so well, like a puzzle piece. So all of the continents actually fit together almost beautifully like a puzzle, and they form one supercontinent. There's that word again. So they're all one big continent, just one mass of land. So they actually gave a name for that supercontinent. They named it Pangea. Let's type that down. Pangea. So basically, Alfred was looking at the map and he said, this looks kind of fishy. They all fit together like a puzzle. I think this must be how they used to sit until over time those tectonic plates have moved, causing those continents to break off from each other and then putting them where they are today. So that's still kind of crazy, right? That's really hard to wrap our brains around. Like, there's no way that's true. Well, we have 3 more pieces of evidence to show that this is probably where the continents used to sit. So the next 3 slides, they say evidence of continental drift on top of the fact that they fit together like a beautiful puzzle piece. So our first piece of evidence, we're going to call these climate clues. Climate clues. So again, if you look at the map, this up here is where we think the continents used to sit all together in one spot, and here's where they are now. So if you look at this top map, you'll see a lot of those countries are farther south, farther toward Antarctica. That's that bottom of the earth. A lot of them are a lot closer to Antarctica or the bottom of the earth than they are today. So especially, let's really look at Africa here. Africa is a hot place to be. If you didn't know that, now you know. Africa, really hot. You're not going to get a lot of snow in Africa. But a long time ago, Africa was really far down south and pretty much connected to Antarctica. So at one point, it was probably a lot colder. And we have evidence of this if you look at the rocks in Africa. So there are a lot of, we call these glacial grooves. Glacial grooves. What are those? So a glacial groove is a groove or like a long line, just like this, kind of like a scrape or a scratch that came from a glacier, which is a big honking piece of ice. So that doesn't make much sense because it's Africa. There's no way we have a huge piece of ice in Africa today. It's way too hot. So we know at one point all of these rocks that are in Africa now must have been somewhere else where it was a lot colder, where all of those glaciers could have existed. So the climate clues, we see evidence of glaciers in places that are super hot today, and it's not just Africa. It happens in India, parts of Australia, parts of South America, places that are closer to the equator or the middle of the earth where it's really hot, and they just can't get ice like that today, so they must have been somewhere else. Another piece of evidence, and I really like this one too, I think you guys will as well, is the fossil clues. So same thing, if you line up all of the continents, well, you know what? Let me back up. Let's look at this map first. Sorry. If you look at the map of the continents today, if you look up here, this is the name of one fossil. We've got this type of fossil over here, and it also exists over here, and over here, and over here. But this fossil is extinct today, and there's absolutely no way that this, in this case, this animal could swim across the ocean. Okay, so this animal has no way of getting from America to Africa. But it's present, or there are fossils present from that species in all of these continents from the same exact time period. And they all disappear at the same time, so they all went extinct at the same time. So that's kind of weird. And it's not just that fossil, it's multiple fossils. Same thing over here. We've got this fossil here, and it's present in Africa as well. But that thing can't swim. How'd it get over there? So if you look again, if you push up all those continents to form that Pangea, that supercontinent again, the fossils line up beautifully, where they clearly all lived together and could have easily walked back and forth between these two pieces of land because they were connected. So at one point when the continents were connected, those fossils were still alive, of course, and they were living their lives moving back and forth because they were so close. They were neighbors. But then eventually those animals died, they became fossils, and those continents slowly drifted apart to be where they are now. So that explains how those fossils got to be where they are. Because again, they couldn't have swam, they couldn't have flown. So there they are. Last one, last slide, last piece of evidence. We have those rock clues. Okay, this one is very, very, very similar to the fossil clues. So basically, if you look at a map of the continents today, this is present day, you've probably heard of the Appalachian Mountains. Some people say Appalachia, I say Appalachian. The Appalachian Mountains, they are on this side of the country. They really go through Tennessee, they go through Kentucky, they go through West Virginia, and they go all the way up. So there is that mountain range, and then there's another mountain range called the Caledonian Mountains that is present in Europe and looks like parts of Asia. So what's the big deal, right? We've got two different mountain ranges, who cares? Well, after scientists have studied the rocks that make up these mountains, they've noticed that they are formed very similarly and they're around the same age. Not only that, but just like the fossil clues, when you line those continents up together, oh my gosh, look at that. They form a beautiful straight line showing that they were once just one long continuous mountain range, one big line of mountains. So they fit together perfectly. They're the same types of rocks. They're formed at the same time. They have the same origins. So we know this must have just at one point been one long mountain range. Kind of crazy. Okay, those are all the clues, so hopefully you're convinced because I'm convinced. So we had the climate clues, we have those evidence of glaciers in the hot continents today. Those fossils, they line up beautifully when you put those continents together, and they're present in different continents where they couldn't have flown or swam. And same thing with the mountains. When you line them up, they line up perfectly. And remember, this is that evidence of that continental drift, explaining that we were all once connected with every other continent in one supercontinent called Pangea, and they eventually, because of those plate tectonics moving from those convection currents, remember that, they are now separated into what they are today. Okay, more crazy stuff that I keep throwing at you, so if you have any questions, please let me know. I'm here to help you.